All right, we're back, and I'm going to talk a little bit more. I'm going to give a couple more examples of graphing some equations. Now, here we've got an equation with a slightly different form. I've got all my variables on one side and a constant on the other, and this one can seem a little bit tricky at times. But we can still do things like make our table, and then, and once we figure out a couple points, we can plot those points and figure out what our line would look like. So let's say we've got our x and y, and I always like to include a couple values of 0. First, I'll try a 0 for the x. So let's figure out what my equation would be if x were equal to 0. So that would be 2 times 0 plus 3y is equal to 6. Although in this case, 2 times 0 is just 0, so I just have 3y is equal to 6. And then I can divide both sides by 3. So I'd end up with y is equal to 2. Okay, let's see what happens when y is equal to 0. If y were equal to 0, I would end up with something. I'm going to shift things around a little bit here for a second. If y were equal to 0, I would have 2x, because I'm not substituting my x variable, I'm substituting my y variable, plus 3 times 0 is equal to 6. Well, since 3 times 0 is just 0, I'll just have 2x on this side. So I'll have 2x is equal to 6. So when I solve this, I'll divide both sides by 2. And I'll end up with x is equal to 3. I've already got 2 points right there. That's fairly nice. Now, I want you to notice that now this is an interesting thing, and it's something that you'll get a handle for later. We could either rewrite our equation in a form called y equals mx plus b, or that's called the slope-intercept form. And that makes it a little bit easier to figure out what multiples we have. But notice that when my x goes up by 3, I increase this by a whole number value. So what I'm going to do is I'm going to instead do something like I don't know, a -3, some other multiple of 3, and see what happens. So let's see what happens when I plug in a -3 for x. I'm going to move down here. So I'll have 2 times our -3 plus our 3y is equal to 6. Well, that's going to be -6 plus our 3y is equal to 6. So this is a little bit more complicated. When I solve this, I'll add 6 to both sides. So I'll have 3y is equal to 12. And then I'm going to divide both sides by 3. And I've got y is equal to 4. So now I've got 3 different points I can plot. So let's go ahead and plot these 3 points. When x was equal to 0, anytime x is equal to 0, it's right here on that y-axis. So when x is equal to 0, y is equal to 2. When x is equal to 3, 1, 2, 3, y is equal to 0. So anytime y is equal to 0, it's right here on the x-axis. And if x were equal to -3, so 1, 2, 3, over here in the minus direction on the x, y is going to be positive 4. So it'll be 1, 2, 3, 4. And sure enough, these all seem to fall in a pattern. So let's see what this would look like. So when I'm plotting this, I will just run a nice smooth line through those. And there's our line. So we could, in fact, choose any value we wanted for x or y. I always like to start with either a 0 for x or for y. And the reason why is these points, wherever x is 0, it's here on the y-axis. This point is called the y-intercept. This point right here So this point right here, where, and that's a B, by the way, where it crosses the x-axis, this is called the x-intercept. And everywhere on that x-axis, y is equal to 0. So we'll have A, 0. In this case, this was 0, 2, and this was 3, 0. Let's do another example. And this is going to be another fairly common type of equation that you're going to see. But yes, these intercepts are it's a very useful concept, and they're going to be very useful tools for us later. But yeah, let's try another type of equation. And this type of equation is a very specific format, and this is a very useful thing. We're going to show you more in other videos of ways to interpret this, because when you know what you're looking for here, you actually have everything you need just at a glance to be able to graph your line. But let's go ahead and get started with just this right now. And we're going to stick with our method of using a table of values. So I'll have x and y. And now the funny thing here is I did say I always like to start with some zeros. I'm going to start with a 0 here for x, but there's another really useful technique that's going to help us here. Oops, I forgot to label my axes. There's another useful technique, and that is we're going to choose some good values for our x. But I'm going to start with just 0 for now. So when x is equal to 0, I'll have 1/3 times 0 minus 2. That's going to be just 0 minus 2, or negative 2. Now, what can be tough with these is I've got a fraction to contend with. And fractions, these are divided up into nice, neat sort of integer intervals. So if we could arrange to have whole numbers, that would be a lot easier. So let's do that. I can take, because I get to choose what values of x we're plugging in. So what I'm going to do is I'm going to choose with something that will cancel out with that denominator. In order to do that, I will choose multiples of that denominator. So here, as long as I choose a multiple of 3, this is going to come out to be a whole number. And let's show you what that looks like. If I choose x is equal to 3, let's show you what this calculation would look like. Y is equal to 1/3 times 3 minus 2. 1/3 of 3, or, well, 3 goes into 3 one time. We'll just have 1 times 1, of 1 minus 2. That's going to be negative 1 right there. Huh. That is a wonderful trick. Let's try it again, see if it holds up. What happens if I plug in x equals 6? So we're solving for the y, but we're just going to say we can set x equal to whatever we want to. It's a variable. It varies. So 1/3 times 6 minus 2. Well, 3 goes into 6. 1/3 of 6 is 2. Oh, 1 times 2 is 2. Oh, 2 minus 2 is 0. Sure enough, we found that 0 right there. And I could keep doing this. I could put a negative 1 in here, or sorry, not a negative 1. How about a negative 3 and see what happens? If I have y is equal to 1/3 times negative 3, 3 goes into 3 once, but it's negative, so negative 1 minus 2. Negative 1 minus 2 is going to be, well, negative 1 minus 2 would be a negative 3. So what happens when I plot these points, we're going to see still a very consistent pattern. When x was 0, y was -2. When x was 3, 1, 1, 2, 3, y was -1. When x was 6, so 3, 4, 5, 6, y was 0. And when x was -3, 1, 2, 3, y was -3. 1, 2, 3. So I see this, I see this very nice, clean pattern. So the tip here, remember, is to choose multiples of your denominator. For x. And that really, really helps you find some nice clean integer values, and that's going to really make graphing a lot simpler for you. You can in fact graph with fractions, but you've got more estimation going on. All right, that's all I've got for now, and I will see you in the next video.